Hi guys, welcome to this set of videos. What we're going to do here in this set of videos is continue our discussion on properties of triangles. In the last section we took a look at the relationship of the interior angles of triangles, and we also took a look at the relationship with a triangle and its exterior angles, and we did a lot of problems dealing with those two properties. What we're going to do here in this section is now take a look at a couple of special cases when it comes to triangles. In particular, we're going to take a look at the isosceles triangle and the equilateral triangle. We'll talk about a few things that I'm sure you guys probably already know about those triangles, but we'll talk about them anyway, and then take a look at some problems that we can do based on those properties of isosceles and equilateral triangles. So let's just jump right into it. As always, we start off a new set of videos and notes with an essential question, and it's simply this: what are the special relationships amongst the angles and sides in an isosceles and an equilateral triangle? Again, I think many of you probably already know these relationships about equilateral and isosceles triangles, but we'll go over them again anyway, especially since we're going to do problems with them, and I don't want to assume that you know stuff that you may not. Again, our objectives are learning targets, the things that we're going to talk about, the stuff that you guys need to know in order to solve some problems or answer this essential question. So here we go. We're going to talk about the isosceles triangle first. So I got a diagram of an isosceles triangle, and again, I'm sure many of you are already aware of these properties of the isosceles triangle, but bear with me as I sort of go through it just to make sure we're all on the same page. First, in an isosceles triangle, right, you are going to have two congruent sides. Two of the sides must be congruent. I missed it. There we go. Yeah, so two of the sides are congruent, right? That's what makes it an isosceles triangle. It is an isosceles triangle if two of the sides are congruent. That's what makes an isosceles triangle. But we actually can go a little bit further than that. Because these two sides are congruent, we talked about this idea in geometry that when it comes to a triangle, the length of the side determines the measure of the angle opposite that side, right? So if this leg right here, right, the angle opposite it is this guy over here. And this leg right here, the angle opposite it would be this guy. Here's the idea with isosceles triangles. Not only do two of the sides have to be congruent, but because those sides are the same measure, the angles opposite them also must be the same measure. Right? These angles have to be congruent, and we're going to call them the base angles. The base angles of an isosceles triangle are congruent. Why are they congruent? Well, because the side opposite the angle are also congruent, and the length of the side determines the measure of the angle opposite that side. So, because this side has the length it has, this angle is going to, and since this side has the exact same length, the angle opposite must be the same measure. Has to be. Alright? So, two things about isosceles triangles: congruent sides. Two of the sides are congruent, which means the base angles are also congruent. Then finally, just to finish things off, that third side, we'll call it the base, and the angle opposite the base is going to be the vertex angle. Now, just with that information, right, the two of the sides must be congruent, and the base angles must also be congruent. We can do all sorts of problems with isosceles triangles, which we'll see here on the next page. So let's go ahead and try a couple of these. I apologize. This first diagram actually has to do with an equilateral triangle, so we'll come back to that one. Let me slide up here. Let's do this one. All right, here's what I know. I take a look at the diagram I've been given, and right away, boom, boom. I know I have an isosceles triangle. How do I know that? Two of the sides are congruent. I know it has to be an isosceles triangle. Two of the sides are congruent. Now keep in mind, what does that tell me? Well, remember, because these two sides are congruent, what do I know about the base angles? Yeah, the angles opposite those two sides must also be congruent. So if this angle right here is equal to x, this angle over here must also be x. It has to be. That's the property of isosceles triangles. Well, boom, just like that, we have everything we need. The interior angles of a triangle must sum to 180 degrees. 3x plus x plus x equals 180. Again, how did I know what that side is? Well, I have an isosceles triangle. So the base angles must be congruent. They have to be the same. Since this one's x, that one's got to be x as well. Once I know the measure of the three angles, set them equal to 180, we solve for our unknown. 3x plus x, there's 3, 4, how about 5x? Divide both sides by 5, and 180 divided by 5 is 36. So we go ahead and plug this stuff in. I know that this has to be 36 degrees. This must also be 36 degrees. And 3 times 36 is going to be 108 degrees. And just like that, you've got the angles that we needed. I got another one for you here. Let's see how this one goes. Awesome. Once again, check it out. They tell me 2 of the sides are congruent. Right away, red flag, isosceles triangle. So because these sides are the same, their base angles, the angles opposite those sides, must also be congruent. So this angle and this angle are equal to each other. Well, guys, this is exactly like the one we just did. 5x minus 2, 3x plus 3, 3x plus 3. The interior angles have to sum to 180. So here we go. 5x minus 2, right? This interior angle plus this interior angle plus this interior angle. What is P? This interior angle? Well, it's equal to this interior angle. So 3x plus, oh wow, oops, not 2, 3. And now I add it again. This is also 3x plus 3. And it's all got to be equal to 180 degrees. All right, I know it looks like there's a lot there, but it isn't. It's a fairly simple algebra problem. Let's combine like terms. 5x plus 3x plus 3x, 11x. Combine like terms. Negative 2 plus 3 plus 3 should be a positive 4. Okay, subtract the 4 to the other side, right? Since it's a plus 4, subtract it to the other side. 180 minus 4, it's going to be 176. Divide both sides by 11, we get 16. And so right away, here we go. 3 times 16 plus 3, feel free to use a calculator. You should get 51 degrees. Again, it's an isosceles triangle. Whatever this angle is, this one has to be the same. So, 51 degrees. And then this guy, 5 times 16, right? Because x is 16, so plug it in. 5 times 16 minus 2, I get 78 degrees. All right, and again, the idea with isosceles triangles, 2 of the sides are congruent, which means the angles opposite those sides are also congruent, what we call our base angles. With that information, you can solve all kinds of problems with isosceles triangles. What we'll do on the next page of the notes, we'll talk about equilateral triangles, and then we'll solve a couple of problems for those guys as well. I'll meet you guys on the next page.